So one of the paradoxes you need to know is the ladder and the barn paradox. And so the paradox is, that the proper length of a ladder is actually wider than the proper length of a barn. However, relativity would suggest that if the ladder is moving really, really fast and we consider the barn to be stationary, that the ladder would undergo length contraction. And so if there's a person standing in the center of the bar, we can call them C. There must be a moment in time where they can press the button, and see that the doors D1 and D2, that they close and then open simultaneously at the same time. And so that's what we're looking at. So it's simultaneous in this reference frame there. So in C's reference frame, the doors will open and close simultaneously. And that we could trap that ladder in the barn, and then it opens. So it opens the door again because it opens straight away, and that the ladder would then continue to move out with some sort of velocity. So in this case here, the ladder's moving to the right. There's a moment in time when C sees the ladder inside the barn because of contracted length, and they can press the button and the doors close instantaneously and then open instantaneously again in C's reference frame. Then, the paradox is, what happens if we consider the ladder's reference frame? Well, if the ladder's reference frame, we have a much longer ladder because the barn has undergone contraction. All right? And so this length here would be contracted. How does this work? That means that there is no moment in time where that ladder could actually fit into the barn. And so this paradox comes undone with this idea of the simultaneous notion of these doors opening and closing in C's reference frame. And so that's what we're going to explore today. All right, so how do we go about this? So I'm going to look at this there, and I'm going to draw this situation. So we're going to take C's reference frame, and I might just make that a little bit smaller. So we can draw our space-time diagram. So the whole idea of this video is that you can use a space-time diagram to support your explanation of this paradox, which is one of your learning intentions for the course. So we put C in the middle. All right, and what we know is that door 1 and door 2, door 1, door 2, and C going up here. And at some point in time, when the ladder is inside that barn, C presses it, the doors open and shut. And that's pretty straightforward. So when we go through and we actually draw this, I don't necessarily think you need to draw this one it's not traveling at the speed of light. It needs to be a little bit steeper. All right, and I don't quite have the length, so I'm actually going to start it inside the barn anyway. So that's the front of the barn, ladder, that's the back of the ladder, and this is A, moving through pretty close to the speed of light. So we've got this length contraction, so that's the front of the ladder and the back of the ladder. And so what this diagram simply shows is that in a moment in time for C, let's say that the doors were extended back down here. This is a bit dodgy. And so the light's coming up and it's meeting at a 45 degree angle. At this particular moment in time, we can see that the ladder is clearly inside the barn. All right, remember time is on the vertical axis. So we have that, because of length contraction, it fits in, which is the easy one to show. What's not so easy to show is the opposite, which is this situation here. As the ladder's moving through, it'll see the barn as contracted, but the ladder will still move through the barn because of simultaneity. And let's have a look at this case. So we're going to put, in this case, we're going to take A's reference frame. And in A's reference frame, the barn and the person C in the center of the barn, is moving to the left. So we'll put A here And I'm going to have to do a really long one to make this work. We call that A. All right, and then we have the front of the barn. No, sorry, the front of the ladder, which stays equidistant in A's reference frame. And the back of the ladder, which is quite long in this case, longer than the other one. And in this case here, we have the barn, which we can say is going to be moving to the left, door 1 and door 2, but moving to the left such that it's still steeper than the light travelling from it. Okay, and so in this case here, you have the barn, D1, we have the C world line, and we have door 2. Okay, now remember, this is all comes back to that C sees the light simultaneous. So well, not sees the light, sees the doors close simultaneous, which means that the light from the door must get to C at a certain particular moment in time. So if we were to project now there was a moment in time for door 2, okay, is if this let go some light here and shone towards C, this would be the time that C would see that light. But I haven't done that far enough away, so I'll just back up. I need to do it up here somewhere. This will be better. So at this particular moment in time, the light traveling in this direction, all right, touch gets to C. Now it has to be simultaneous in C's reference frame. So as we go back down in this direction, the light must have left door 1 earlier, okay, which means that door 1 would shut earlier in A's reference frame. So I'll just continue this out here. So what this is saying here is that the light reaches C at the same time, which means that the light from this point in time, remember time is snapshots across time as this, reaches A at this particular moment in time, okay, and the light reaches from the back door reaches A at this particular moment in time. So there is this change in distance between these 2 points here, a change in time, I should say. My mistake. There's a change in time where A sees door 1 open first, followed by door 2. So what does that look like then in terms of the paradox? If door 1 open and shut before door 2, how would the ladder still pass through the barn unaffected? So here's the barn, all right? Here's the barn with door 1 shut. And here is the ladder, nice and long. Okay. A moment in time later, the barn shuts its back door, but it's opened its front door, which means the ladder can continue to pass through unaffected by the barn doors. Okay, so the front door closes and then opens first as the ladder is still hanging outside the barn, and then later, once the ladder's gone through, okay, the back door shuts and opens again. And this has all got to do with this idea that the light reaches A, which are the red lines intersecting with the middle world line at different times. So even though it's paradoxical in nature, it's still possible in the world of relativity.